All right, ladies and gentlemen, I am here, Miss Fashour, to talk to you today about some properties that have to do with division. When we look at powers and exponents and things like that, we've spent a lot of time talking about multiplication, the product of powers and powers of product and all that kind of good stuff. But today we're going to talk about the quotient of powers property. Just one quick little property. We're just going to apply that to some fractions, because when we talk about quotients, we talk about things like 25 divided by 5. That's a quotient. But we also talk about 25 divided by 5. That's also a quotient. So any sort of, fraction, those aren't equivalent, but you know what I mean. Any sort of fraction is also a quotient. And then we're just going to do some quick real-world examples and some fun problems with what are called fractals. All right, so here we go. Why don't we start with some things that we know? One thing that we know is that, let me see if there we go, that's what I like. Any number divided by itself is 1. Okay, that's going to be key when we start talking about how we can discover this property that has to do with division. Okay, so what we're talking about is this idea of obviously 3 divided by 3 is equal to 1. Or any number that's the same here as it is here. Okay, anything that is the same on top as it is in the bottom is going to kind of cancel out. So what happens is, if we have this example here with 3 to the 4th over 3 to the 2nd, 3 to the 4th is the same as 3 written 4 times. 3 to the 2nd is the same as 3 written 2 times. So I'm just writing those out. And if you were to look back at what we have up here, where 3 over 3 is 1. Anytime you see a 3 over a 3, those can cancel out because it's as if you're saying, oh, 3 over 3 is equal to 1. So they're canceling really, they're not disappearing, but what's happening is 3 divided by 3 is equal to 1 and 1. They become 1s. Okay? It's kind of like when you think about cross-canceling with fractions. Okay? If you were to do 3 over 2 times 10 over 3, because there's a multiplication in here, we can cross-cancel, making them 1s. Okay? The same kind of thing happens here. I can cancel out a 3 and another 3, making them 1s. I can cancel out another pair here, making them 1s. And so really what we're going to get here is, oh, and you know what? I had a prettier way to write it. What we're going to get here is just 3 to the 2nd power. Okay, if you think about the activity we did in class on Monday, we are going to hopefully look for some patterns here. The same thing with the 6s. Okay, so 6 7 times is up here, 6 3 times is there. Really, if you think about, this is a pair that cancels, and this is a pair that cancels, and this is a pair that cancels. What do we have left? We have 4 6s. So hopefully you can kind of look for a pattern. What's going to happen here? And what's going to happen here? The 7, the 3, and the 4. If you're thinking about canceling out instead of putting things together like we do when we multiply, here we have 3 2s and then another one. We kind of put them together. In this case, we're canceling things out. What operation comes to mind? Subtraction. Okay, so to divide powers with the same base, keep the base and subtract the exponents. Okay, if you're looking for a formula for that, usually we would write something like a to the m over a to the n equals a to the m minus n. Okay, notice when you subtract, the order matters. Okay, so it's the top one minus the bottom one in that order. Also, remember that they have to have the same base. Okay, that was key before. I'll give you guys a second. You could pause and write that down and come back to me when you're done. All right, so we're moving on with some example problems here. I'm going to do the first 3, and if you're ready to try it, feel free to just kind of work them out on your own. You can pause the video and come back when all the answers are here, but I'm going to go through the first 3 together, and then I'm going to officially give you guys these 4, 5, and 6 to do on your own. Okay, you try. If you're not ready to try them on your own, well, then stick with me. We have a situation in the first problem where we have the same base. Okay, we got to check that off. Check, same base. The base is negative 3. So really, we're going to have negative 3 to the power of 9 minus 3, because I am subtracting these exponents here. Okay, that should give me negative 3 to the 6th power. Okay, notice it says simplify Oh, but then it says evaluate. Okay, so evaluate does mean to write it out. And 3's aren't so bad. I know it looks like a lot. But what we can try and do here is maybe put some groups together to make life easier. This is going to give us 9, right? And this is going to give us 9. And this is going to give us 9. Notice how those are positive. Because every time you have a negative times another negative, you get a positive. So basically, all our negatives kind of cancel out. And all we really have is 81 times 9. 81 times 9. This is a 9. And 72. So 729. If the problem says to evaluate, it means you're actually writing out the multiplications and you're figuring out a numerical answer to end. Clearly, we're not going to really be able to do that here because we're given variables instead of numbers themselves, but that's what we're looking for when it says evaluate. If it just says simplify, then you can leave it. We could have left it like this if it just says simplify. Okay, the next one is putting together a few different things that we know about exponents, trying to kind of combine some of these properties. Here, I think that if it were me doing the problem, I'd want to attack that first. All right, so I have the numerator with exact same bases, so that should be 5 to the 12th power. Why? Because you add the exponents. Now I can do my little property that I just learned where I'm subtracting. Remember, 12 minus 7 is 5. 5 to the 5th power. You can punch that in your calculator. I'm totally cool with that. 5 to the 5th power. Go ahead, find yourself a calculator. I'm finding myself a calculator. Punch it in. It should be, let's see if I have this 5 times. It should be 125 times 25. And you know what? You guys grab a calculator. You can fill that in. And I'm going to go on to the next problem. Maybe I'll find myself a calculator and come back to it. Number 3 is variables, but it's the same idea. What I want you to understand with number 3 is that this x to the 6th power is really on the top. Okay, if you have the number 3, how do you make it look like a fraction? You put it 3 over 1. If you have the number 10, 10 over 1. Any whole number, you just plop a 1 underneath it, and it looks like a fraction. So this is 1 over x to the 4th times by x to the 6th over 1. Okay, when we multiply fractions, we're just multiplying across. X to the 6th over x to the 4th is x to the 2nd. And we're done. Did you guys figure out number 2 for me? 125 times 25 is 3,125, yeah? And then these last 3 I want you to try them. So pause, and I will reveal the answers when you come back. Okay, hopefully you've tried numbers 4 through 6. These are your answers here. Oopsie. Sorry, that's kind of covered up. I gave you a little trick problem. Sorry about this. I really wanted you to make sure you were taking the time to make sure these bases are the same. So if you're trying to put those together, you can't really put them together. This one, I guess I didn't write out 9 to the 5th power as far as one numerical answer, but you could leave 9 to the 5th. Same thing here. Y to the 3rd, that's totally fine. All right, let's move on. What we have next is this idea of when we're talking about dividing, we also have to talk about fractions because they kind of go hand in hand. What should I do if I'm given a fraction with an exponent on it? Okay, this is very, very similar to this problem. Okay, I'm making up different variables, but the ideas are the same. If you have two things, an A and a B, inside your parentheses, this x, the variable, or I'm sorry, the exponent in this case, needs to be applied or given to both of them evenly. A to the x times b to the x. The same type of thing happens here with this 4. Okay, this problem here is a product, two things being multiplied. This one here is a quotient. It's gonna work the same. It's gonna, numbers are gonna have the same type of pattern, the same idea. If I have 2/3 to the 4th power, that means I'm writing that out. You don't have to write it out once you know the property, but I'm trying to get you guys to understand the idea. I've written 2/3, 1, 2, 3, 4 times. 2/3, 2 over 3 to the 4th power. Well, how many 2's do I have? I have 4. How many 3's do I have? I have 4. So really, that's the same as, I don't know why I wrote it again, 2 to the 4th over 3 to the 4th. Okay? So now that we know the property, it is perfectly fine to go from here to there, but I want you guys to see that this exponent of 4 gets applied to the 2, gets applied to the 3, both the numerator and the denominator. Okay, when raising a fraction to a positive power, raise both the numerator and the denominator to that power. Okay, so take a second to write that one down. Hopefully you're back from writing that down. And we have some examples here. The first one I'll just kind of walk through. This last one, I think you guys should give it a try. That looks really fun. So we have this idea of needing to apply this 3 to both the 3 and the 4. Okay, so it becomes 3 to the 4th power, 3 to the 3rd power, 4 to the 3rd power, and we have 27 over 64. That's our final answer. Okay, do you guys want to try that one? Why don't you try number 4? Push pause, give it a try. It'll wake you up. All right, hopefully you're back. If you gave it a shot, I'm super proud of you. Even if it's not right, at least you're giving it your best effort. The 3 needs this 4 to be applied to it. The d to the 2nd power needs the 4 to be applied to it. The e becomes e to the 4th, and the f becomes f to the 4th. Okay, do you see how? This is going to get a little sloppy, but there's 1, 2, 3, 4 kind of items inside of that parenthesis. The 3, the d, the e, and the f. What happens to your final answer? Hopefully, you have 81 d to the 8th, over e to the 4th, f to the 4th. All right, I'm sure you gave it your best try. Let's keep going. What we're going to do next are a few example problems. This one has to do with science. It says a light year, or the distance light travels in 1 year, is almost 10 to the 18th centimeters. To convert this number to kilometers, divided by 10 to the 5th. Okay, divided by 10 to the 5th. Now, 10 to the 18th is really just a 1 with 18 zeros, right? And 10 to the 5th is just a 1 with 1, 2, 3, 4, 5 zeros, right? But do I really need to do that? Do my properties of exponents help me out to make this a problem much easier? I hope you're saying yes. 10 to the 18th divided by 10 to the 5th. All we really need to do is subtract the exponents, 10 to the 13th. And we're done. Okay, how many kilometers is a light year? 1 light year is 10 to the 13th kilometers. Okay, because it is a story problem, we want to label it. 10 to the 13th kilometers is equal to 1 light year. Even clearer. I hope that's what my answer says here. Oops, slide down, pay attention. Yeah, 10 to the 13th. Okay, I have one more little kind of challenge problem. I think that what I'm going to do is I'm going to let you guys play around with it a little bit. I'll maybe give out some extra, I don't know if we'll call it extra credit, but what I'll have you guys do is attack this problem tomorrow in groups and see if put your groups together you could figure it out. Just give it a try. All I'm asking for is a try. I am going to count this as part of your notes, having your homework being done. So read it out. I'm not going to read it to you. Read it out and see if you can figure out what they're looking for here. Part A does say make a table. Okay, so make a quick little table. It looks like this and this. This is a really cool problem because it introduces some examples of what we're going to get to later in this unit called exponential functions. Okay, it introduces an example of an exponential function. Okay, so give it a try. Give it a try. And I will see you guys tomorrow. Hopefully you are feeling good about our objectives. Discover the quotient of powers property. We talked about that. It has to do with subtraction, right? If they have the same base. We applied this to fractions. Okay, what if I have 2 to the 3rd power, to the 2/3 to the 4th power? And then we did some fun little examples of science, real world, and some other fun explorations of exponential functions. Okay, so have yourselves a great evening, and I will see you guys tomorrow.